Here we go. This is lesson 5. Hey, if I have an angle, I start with an initial side. And then, according to my rotation in degrees, I land at my terminal side, right? That's what that is. There's an initial side and a terminal side. I have told you this before, right? If we rotate from our terminal side, if we rotate counterclockwise, we are rotating in a positive direction. That's positive degrees. If I rotate in a clockwise direction, I'm rotating in a negative direction. So in other words, negative 180 degrees and positive 180 degrees are going to take me to the same spot. This is a picture. Don't write it down. We're moving on. Okay. It tells you about reference angles. We're going to actually just use it. It'll make more sense than this picture when we do it. Okay. Hey, coterminal angles is actually quite important. I'm going to use this this term a lot. So go ahead and write that bad boy down, and then I'll explain it. So, the way this works is, if this angle right here is 50 degrees, it's too big. Okay. Then a coterminal angle would be, if I start from the same terminal ray, right? So this right here is my terminal ray, or my initial, sorry. And then my terminal will go like this. So check it out. It's going to look like this. So I start here. I went 360 degrees, right? Yeah. And then 50 more. Where does that put me? 410 degrees. My reference angle would be 50 degrees. But the angle that I actually formed was 410 degrees. So the angle is 50 degrees and 410 degrees are coterminal angles because they really put us in the same spot. Right? We wind up in the same spot in terms of rotation. 770 is just going to be another rotation. So that's for positive. If I was going to go negative, it looks like this. We've got our original 50-degree angle. Remember I said negative was going clockwise, right? So, I'm going to start here. And I'm going to go negative, boom, and stop there, right? How many degrees is that? It's going to be 360 minus 50, right? So, a negative coterminal angle would be negative 310, okay? But remember, I'm going negative degrees if I'm going clockwise, okay? See that? So let's put this to use. Here we go. Let's find cosine of 405 degrees. And then we'll identify the measure of the reference angle. I'll refer to our unit circle, and you will too. Okay? Check it out. 405 degrees is more than one rotation around the circle, right? So what we got to figure out is how much more. Yeah? So, and we could say that cosine of 405 degrees is the same thing as cosine of 405 degrees minus 360. That's going to tell us how much more than one rotation this is, right? It turns out to be cosine of 45 degrees. All right, let's look at our handy dandy unit circle. I feel like I should use this. Okay, so how did this work? We went 360 degrees, right? And then in order to get to 405, I had to go, there is a line here, right? I had to go 45 degrees more. Good job. So, 45 degrees and 405 degrees are coterminal angles. And you recall that cosine theta is x and sine theta is y, right? So that means that cosine of 405 degrees is the same as cosine of 45 degrees, which is the square root of 2 over 2. We can also answer the other question that was there already, right? What is sine of 405 degrees? It's going to be my y-coordinate at the coterminal angle of 45 degrees. So let's go ahead and answer. So that is the square root of 2 minus 2. And then likewise, we could say that sine of 405 is equal to sine of 405 minus 360, which is the same thing as sine of 45 degrees, which is also okay. Nope. Let's do 840. So hey, if we go 360, we're not there yet, right? We could do another rotation that takes us to 720, right? We're not there yet, but what we want to do is we want to not be 360. You know what I mean? We want to go 360 degree rotations until we have less than 360 degrees left. Okay? So for instance, let's go ahead and do it on the unit circle. I'm going to start in the middle. So I go 360, right? 720. And now what do I have left? I have 120 degrees left.
Yes.
So now I'm going to go 120 degrees, and that puts me right there, right? So 120 degrees, and was it 840? So yeah, 120 and 840 are the same, right? So I can figure this out by going 840 minus 720. That's how I got that. And what is our x coordinate at 120 degrees? Yeah. Right dang. -1/2. All right, and then likewise, sine of 840 is the same thing as the sine of 840 minus 720, which is the same thing as sine of 120 degrees, which is what? 3. Yeah. Did you already eat it? Do you want a different flavor, dude? You like orange? Okay. Do we need to do another one? Let's. One more? Huh? Okay. That's it. That's how you do it, right? Let's look at negative angles, though, all right? Negative angles, okay. So cosine of negative 30 degrees. Now remember, we're now going around our unit circle in a clockwise motion, right? So, what is negative 30 degrees? That puts you right there, right? So negative 30 degrees and positive 330 degrees are coterminal angles. And so then I can look, what is cosine of 330 degrees? Root 3 over 2, right? So cosine of negative 30 degrees is equal to root 3 over 2. And sine of negative 30 degrees is going to be my y coordinate at that point, which is negative 1/2. All right. So 2 minutes. All right, negative 135 degrees. Let's look at our unit circle. Have you noticed I could also just go 360 minus 135, and that'll tell me where to go, right? So 135, so there's 90, right? And then 45, so that puts me right there, which is at 225. So cosine is going to be negative root 2 over 2, and sine is going to be negative root 2 over 2. And the rest, I'm sure you can do. It's just it's just an extension of the same. If you would like, you may ponder this question.